All right, so let's go over some examples on how we find the domain with log functions and trig functions. So first one we have the logarithm of 2x minus 12. So let's remember what a logarithm is. It's essentially an exponential. In this case, the base is 10. So what this is saying is 10 to the y is equal to 2x minus 12. This is important so that you understand how we find the domain and why we find it to be essentially the values 2x minus 12 that are positive, because there's no value that you can raise 10 to. There's no number for y that will make 2x minus 12 negative or even 0. Like you can make y negative or positive or a fraction. It's not gonna make 2x minus 12 a negative number. So when we're solving for the domain, what we essentially are doing are just finding the set of values that will make 2x minus 12 greater than 0. And then we just, use some good old algebra. And that would just be the values where x is greater than 6. Interval notation, it'll just be open parentheses, 6 comma infinity. All right, so number 11, we have y is the square root of the tangent of x, and our domains or values of x can be from 0 to 2 pi. Now, let's remember what the tangent of x is equal to, and that is the sine of x over the cosine of x. Now, this is key because we want to find values that will make the tangent of x 0 or greater, since we're taking the square root of it. So then we essentially are going to make this greater than or equal to 0, and we just solve for the values that will satisfy this inequality. So the sine of x, this will be 0, and that will make the whole thing 0. And what we want to find then are when are the sine. So let's pick like cases. Case 1, they both could be positive, like positive over positive, right? We'll make the whole thing positive. And like case 2, I guess. I don't know why I'm all about these cases, but case 2 would be if they're both negative, and negative over negative would make, a positive number. So let's find where they're both positive and where they're both negative. And the third case is just when the sine of x is equal to 0. So for case 1, they're both positive in quadrant 1. Let's remember our unit circle. Should have this key. Remember, this is quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. And this is where we start at 0, pi over 2, pi, 3 pi over 2, and then we go back to 2 pi over here. So in quadrant 1, there I am. Quadrant 1, they're both positive because sine and cosine are both just x and y values, so they're both positive here. And they're both negative in quadrant 3 because the sine, again, is below the x-axis and the cosine is to the left of the y-axis. So then this would be on the interval from 0 to pi over 2. And let's remember if sine is positive, or sine at pi over 2, cosine is 0. So we can't include pi over 2 because we would be dividing by 0. So we would go up to pi over 2. You can write usually a comma. I like to use a union. And we start up again back over here in quadrant 3. Quadrant 3, the cosine and sine are both negative. So this is at angle pi. But let's remember, like what would make sense is that you can include pi in this case because the cosine is -1 and that's fine. And we would go back to 3 pi over 2, but we wouldn't include 3 pi over 2 because the cosine of 3 pi over 2 is 0. And we can't divide by 0, so we would use a parentheses. And this would just be our answer here, this interval. There. So you can think of it as on number line. We include 0. We work our way to pi over 2, but we have an open circle at pi over 2. We skip, we jump, and start up again at pi. We include pi. And we go to 3 pi over 2, but we don't include 3 pi over 2. We have an open circle at 3 pi over 2. I always like having a visual because it really helps me. I think it helps you guys really understand what's going on with these problems. And now the last one, y equals x over the cosine of x. We just can't have it so that the cosine of x can't be 0. Because we would be dividing by 0. So we want to understand, when is the cosine of x equal to 0? Well, going back to the unit circle, it's equal to 0 at the top, you know, at pi over 2. And then at the bottom, 3 pi over 2. If we went again, we would be rotating to 5 pi over 2. So then, let's do this. X can't be, you know, pi over 2. Three pi over 2, 5 pi over 2, and that this pattern would repeat. However, we have to also remember this little technicality because it could be positive or negative. So we would make sure that it can't be positive or negative 3 pi over 2, pi over 2, 5 pi over 2, 7 pi over 2, because being negative just means you rotate the other way. It means you're going in this direction. And this would then be negative pi over 2. So negative pi over 2. So be careful of that little technicality because this would be the formal answer, I guess.